Prior to 2006, programs were written only on MapReduce using Java programming language. Developers had to mind the map, sort, shuffle, and reduce fundamentals while creating a program for which they needed common operations such as joining, filtering, and so on. The challenges kept building up while maintaining, optimizing, and extending the code. Consequently, the production time increased. Also, data flow in MapReduce was quite rigid, where the output of one task could be used as the input of another. To overcome these issues, Pig was developed in late 2006 by Yahoo researchers. It later became an Apache open source project. Pig is another language, besides Java, in which MapReduce programs can be written. Pig is a scripting platform that runs on Hadoop clusters designed to process and analyze large data sets. Pig is extensible, self-optimizing, and easily programmed. Programmers can use Pig to write data transformations without knowing Java. Pig uses both structured and unstructured data as input to perform analytics and uses HDFS to store the results. Yahoo scientists use grid tools to scan through petabytes of data. Many of them write scripts to test a theory or gain deeper insights. However, in the data factory, data may not be in a standardized state. This makes Pig a good option, as it supports data with partial or unknown schemas and semi- or unstructured data. There are two major components of Pig: Pig Latin script language, a runtime engine. The Pig Latin script is a procedural data flow language. It contains syntax and commands that can be applied to implement business logic. Examples of Pig Latin are load and store. The runtime engine is a compiler that produces sequences of MapReduce programs. It uses HDFS to store and retrieve data. It is also used to interact with the Hadoop system, HDFS, and MapReduce. The runtime engine parses, validates, and compiles the script operations into a sequence of MapReduce jobs. Pig's operation can be explained in 3 stages. In the first stage, the data is loaded and a Pig script is written. In the second stage, the Pig execution engine parses and checks the script. If it passes, the script is optimized and a logical and physical plan is generated for execution. The job is submitted to Hadoop as a job comprising of map and reduce tasks. Pig monitors the status of jobs using Hadoop API and reports the status to its client. In the execution stage, the results are dumped onto the screen or are stored in HDFS, depending on the user command. Developer and analysts like to use Pig as it offers many features. Some of the features are as follows: provision for step-by-step procedural control and the ability to operate directly over files. Schemas that, though optional, can be assigned dynamically. Support to user-defined functions, or UDFs, and to various data types. As part of its data model, Pig supports 4 basic types. The first is atom, which is a simple atomic value like integer, long, double, or string. The second is tuple, which is a sequence of fields that can be of any data type. The third is bag, which is a collection of tuples of potentially varying structures and can contain duplicates. Finally, there is map, which is an associative array. The key must be a character array, but the value can be of any type. By default, Pig treats undeclared fields as byte arrays, which are collections of uninterpreted bytes. Pig can infer a field's type based on the use of operators that explain a certain type of field. It can also use user-defined functions, or UDFs, with a known or explicitly set return type. Furthermore, it can infer the field type based on schema information provided by a